Hello, I'm Michael, and today I'm discussing for my 6-minute talk magnetic drives. So the overview of the presentation, we're going to discuss what it is, how it works, we're going to compare it to a conventional drive, the reasons that you would use a magnetic drive over a conventional motor drive, and advantages and disadvantages and how it relates to thermodynamics. So what is it? It's an external magnet placed in the drive shaft that transmits motion to an internal magnet that connects to the impeller. We'll go through some pictures later, maybe if you don't understand that, you'll see. The impeller rotates and moves the fluid through the pump or compressor, and then torque is transferred to the pump compressor housing via magnets. So how does it work? The outer and inner rings contain the same number of identical matched and opposing magnets arranged with alternating poles around each ring, as you can see in this picture. The maximum torque is determined by the gap between the magnets. Okay, so now we can compare the conventional versus magnetic drive. I kind of set these up the wrong way. So this is a conventional drive. You can see the motor shaft is the blue shaft going into the orange impeller is the orange thing in there that can spin, like a pump or compressor. So it spins it, and it compresses the fluid. And the problem with this, you have to have a seal on the conventional drive. And you can see that there's a little leak coming out, and in turn, because it's leaking, you have a slight pressure drop. And if it's like a hazardous or toxic fluid, you could also have issues with that. Now you can compare it to the magnetic drive, where the motor shaft spins a housing that contains magnets, and there's magnets on the inside of the pump as well. So when it spins the outside one, it could spin the inside one without breaking without there having to be any seal. So there's no hole that you have to seal to go into it. So it's a perfect hermetic seal, and there's no chance of fluid leak. I guess there's always a slight chance of fluid leak, but not because of the drive. Okay, so the reasons that you would use a magnetic drive over a conventional drive is so the internal and external magnets are separated by a casing, which creates a hermetic seal of the liquid in the pump or compressor. So it's often used when working with fluids that are hazardous, corrosive, flammable, explosive, or toxic. So just in case there's any leaks or anything like that. So this is an example that I made on SolidWorks, just kind of to get an understanding. So a motor shaft would connect to that blue ring on the outside, and it would spin that by in turn, and the gray part would be connected to the actual pump or compressor. So the motor would spin the blue part, which would in turn spin the green part, which is going to be connected to another shaft that's connected to the pump or the compressor. And by spinning those, you spin them without breaking any seal. So the advantages of the magnetic drive. Hermetic seal, so there's no pressure loss as seen with conventional pumps and compressors. Very low risk of fluid and vapor leaks. Minimal maintenance if used for normal operation. And no need for alignment of pump or motor because it easily couples to each other. Disadvantages: cannot be used for applications that involve even a small percentage of solids because the fluid is actually inside of the magnetic drive, so it could damage it. Requires higher power absorption than conventional pump and compressor, and it's definitely more expensive. So how this relates to thermodynamics is the inner magnet ring is immersed in the working fluid, so it acts as a lubricant and coolant to keep the magnetic drive from getting overheated. So it's sitting inside the actual fluid as opposed to normal. They're often used to operate pumps and compressors that are working in a thermodynamic cycle that has a dangerous chemical acting as a working fluid. And the work produced can be increased by reducing the gaps between the magnets. Any questions?
Yes.